All right. Looks like we can start. So welcome to the HTTP2 session at scale. My name is Shadrin, and in this session we will talk about this new version of the HTTP protocol, about its use cases, about how and when to use it and when not to. First of all, a little bit about myself. I work for NGINX in San Francisco as a technical solutions architect, and I often deal with lots of our users and commercial customers as well, figuring out the technical questions and challenges that the current internet users have, and figuring out the solutions for their environments. I have quite a long experience in web technology. Basically, since I connected my computer to the network, I was dealing with different forms of websites. Basically, first of all, creating the websites, securing them, sometimes figuring out how to make them work faster, and all the reasons around it. So my contacts are right there. It's nick@nginx.com, or you can tweet me at Shadrin. So first of all, I used a lot of different links to different resources in this slide deck, and I collected all those links in one page. So this slide with this QR code, I will leave it after the presentation as well. So don't bother taking pictures of every slide, because the slide deck is also available on the conference website. All right. The first part of the talk, we will see the difference between the HTTP and the HTTP1 and the HTTP2 protocols. We'll talk about what features the new version of HTTP gives us, and what kind of new enhancements and new performance benefits you can get just immediately from using that. We will review the HTTP1 and the HTTP2 optimizations. Most of us who wanted to make their websites work faster, well, we have already implemented some features for HTTP1. So we'll see how an immediate use of HTTP2 can either benefit or degrade performance, depending on what optimizations you use for your old school HTTP1 deployment. We'll see very interesting ways of troubleshooting the HTTP2 protocol. It does have some challenges there. It's not as straightforward as HTTP1 troubleshooting. And the next part, we'll see a very interesting part, the benchmarks. Everybody can make their own benchmarks, and there is a number of different benchmarks available for comparing HTTP1 and HTTP2. And obviously, I made my own benchmark, and I will tell you why mine is better than everybody else's. All right, and then we'll talk about how to configure it, how to do that with the NGINX web server, and which features to enable, what kind of configuration and log items to expect. All right. So first of all, little bits of the HTTP history. It's been a while since HTTP received a major update. First of all, it appeared, the first draft appeared in the late 80s, beginning of the 90s, and with the version 0.9, there was a very simple way of accessing an HTML page using a very simple GET request to the URL. So there was no concept of keeping the stateful connections there. There was no concept of different resource types, caches, or all the other optimizations that we currently have. In 1996, the HTTP version 1.0 was finalized with some of those enhancements. But what we are going to be comparing with HTTP2 today is going to be the HTTP 1.1. The major features of HTTP 1.1, which were added compared to 1.0, are the keep alive connections and extended abilities to control and manipulate the cache. And there's also a number of other different features, but performance-wise, the keep alive and caches are very important for us. And in 2015, about less than a year ago, it was the HTTP 2 version was finalized, and HTTP 2 was based on the open protocol called SPDY. So currently we have a proper standard, not some protocol developed by a set of companies, but a properly defined standard version 2 of the HTTP protocol. So let's take a look at the example request and example response in HTTP 1. First of all, who is familiar with the HTTP headers and the HTTP request and everything? All right, so I guess we can just skip this slide. Looks like everybody knows HTTP 1.1 well enough. So let's take a look at the predecessor of the HTTP 2 protocol, which is called SPDY. It was announced in 2009 by Google, and it became very popular with the implementers of the web servers and implementers of the web browsers. So SPDY is well supported, and the major idea for the SPDY protocol was to reduce the page load time and to make performance enhancements to the HTTP 1.1 protocol. So major features of SPDY included the compressed headers, the flow control with multiple streams of data, and the server push. Compressed headers with SPDY, the compression was done with the gzip algorithm, and we all know that all the HTTP 1.1 protocol can also compress data, just as SPDY can compress data, but HTTP 1 cannot compress the headers. And when you have smaller requests, when you have a large number of requests or a lot of headers are flowing through a network, having that data uncompressed, it sometimes degrades your performance. So HTTP 2 was introduced in 2015, and it's majorly based on the SPDY protocol. The difference between SPDY and HTTP 2 is in the method of compressing the headers. HTTP 2 does not use gzip compression. It uses HPAC compression, and it makes basically it makes a map of the headers and data on both the server side and the client side. So that compression becomes stateful, and for the implementation of HTTP 2 with the proper HPAC algorithm, it does use significantly more memory, because all the compression data needs to be stored on both sides, both on the server and the client side. The multiple streams of data allow you to put different requests inside the same TCP connection, and the different request data is and response data is coming through that connection in the same time. So basically, we all know that in HTTP 1, the browsers tend to open multiple connections to the same server in order to download images, CSS files, and other resources in parallel at the same time. With HTTP 2, that is performed within one connection, and the implementers of the browsers do not open several connections to the same host. Everything is done within one, and it is done with the prioritization. HTTP 2 allows to send the priority information with every stream of data. So the browser can know which data it needs the most, which data it needs to come with more priority, which data is less required for the user to start interacting with the page. And also, HTTP2 includes the server push, the server push feature. The server push allows you as a website builder to send data to the client without the client's prior request for that data. Basically, you will be sending the request and response together in the response. So you will tell the browser what the browser should have asked for. It makes total sense when you have high latency networks, for example. When someone is asking for an index.html page, you already know that they do need the javascript.js and style.css. So you can push that information to the client. Also, what you can do is interact with, make your pages more interactive. For example, when you need a notification to be pushed on your page, or maybe some interaction data like chat style workflow when the data is flow in both directions. So it can be used as a way to work around the WebSockets as another method of sending data in both directions. All right. There is an interesting question about encryption and HTTP2. If we look into the specification and we look at the standard, it doesn't require that the connection would be encrypted. However, no implementers of the web browser have implemented the use of non-encrypted HTTP2 traffic. So every browser will only support HTTP2 when the connection is done with TLS. So due to this particular need for everything to be encrypted, we at NGINX also included the encryption version only for HTTP2. There is an interesting way of how does the browser know how to initiate the connection. There are several ways of doing that. First way of first way of switching the protocol from HTTP 1.1 into HTTP 2 is to send an upgrade header and to switch the protocol from HTTP 1 into HTTP 2 using that the upgrade header functionality. Basically, you will tell the client will tell to upgrade the connection to HTTP to send the data with a binary format. Another way of doing that, it's called the NPN. It's called the Next Protocol Negotiation, and it is an extension to OpenSSL, which allows the client and the server to negotiate which protocol they are going to be using for that particular connection. And that negotiation is done early in the TLS handshake, so we can avoid the use of HTTP 1 completely in that particular connection. There is also another way of performing negotiation to HTTP 2. It's called the ALPN, Application Level Protocol Negotiation. The difference between those two extensions is that ALPN basically saves you an additional round trip in negotiating the protocol. And basically, at the first handshake, the client sends the list of the protocol that the client is supporting. The server picks HTTP2 from the list and starts sending data to the client. In the NPN negotiation, the server is announced in the list of protocols. The client picks the protocol, and then the connection starts. So there is a difference in OpenSSL versions that support NPN and ALPN. NPN is supported in OpenSSL 101, which is currently used in the most long-term support and I would say enterprise-friendly, well-supported Linux distributions. However, the ALPN negotiation is supported from the OpenSSL version 1.02 and onwards. And that version is not included into some of the very popular Linux distributions currently. Obviously, we expect that to be changed soon, so ALPN will be supported everywhere. If we would talk about Ubuntu Linux, the version 15.10 supports OpenSSL 102, and version 14.04, the long-term, the LTS version, it does not. So that kind of limits us in some implementations of the protocol negotiation. Another thing to mention is that NPN negotiation is supposed to be removed from the browser support pretty soon, along with the support of the SPDY protocol. So we need to align our servers and our infrastructure to support and to work with the current versions of the web browsers. So if the web browsers are dropping the SPDY support, we will have to switch to HTTP2 at some point. When the browsers are removing the NPN support, we will have to switch to the versions of our server software which supports OpenSSL 102 and ALPN. All right, next let's go through a number of different optimizations that we can perform within HTTP1, and let's see how those optimizations affect the website if we are switching from HTTP1 to HTTP2. The first optimization is called the domain sharding. We know that the browser opens a number of connections to the same host in order to perform the file downloading simultaneously. So when the browser opens only up to 6 connections per host, and sometimes when we want to when you want the browser to download more resources at the same time, we put our resources into the different subdomains or into a set of completely different domains like www1, www2, and so on. That way, the more domains we implement, the more connections the browser will open, and potentially, sometimes I would say it becomes a little bit faster. Last name Shadrin.
Okay, read that top slide here and notice if your name is in the second word.
Thank you. That was on purpose. Yes, I was told that all the time, especially when I was dealing with the database Shadrin.
Memory's in your fingers.
Yes, that is correct. All right. So basically what we're doing with the domain sharding is we are distributing the resources across multiple domains, and we're making the browser to download those resources at the same time. So you already see that it doesn't help with HTTP2. It does not, because opening multiple connections and messing up with HTTP2 priorities, it's not going to be that intelligent on the network level as it's going to be done on the browser prioritization level. So making that making that optimization more aware for the browser, so the browser will be able to choose which resources to download first and with which priorities. It makes significantly more sense. So if you are using the domain sharding features and you are switching to HTTP2, it makes sense to simplify it and go with the same CDN domain, or even just the same domain for everything. It also depends on somewhat depends on the geographical distribution of the website and the CDN use. Another optimization that many people implement for making HTTP1 websites faster is making the image sprites, basically combining multiple images into the same large image file. And on the client side, you can easily carve that into different smaller pictures, smaller pictograms. It's pretty easy to do that with the client-side technologies. So does it help with HTTP2? Well, a little bit. So the if you start sending multiple requests instead of one larger request, it does not affect performance in HTTP2 as much as it affected it with HTTP1 because of the compressed headers, because we're using the same connection, and because we're sending the data within the same, through that same connection, we're sending the multiple streams within the connection. Another method of optimizing is concatenating the JavaScript, the CSS files, and using that is very similar to the image spriting. What you're trying to avoid when you're doing that is not sending the set of headers all the time to reduce the amount of round trips on your website. And that's exactly the same as with the image sprites. If you are using HTTP2, it does not affect, there is not much effect in doing that. And there is a downside of using those optimizations. And all of those optimizations, they add to your time. They add to your DevOps time. To you will need to create those subdomains. You will need to manage those files, create the deployment scripts and scenarios, which are more complicated than if you would be using the HTTP2 protocol and not those complicated optimizations. So let's look at the current statistics of HTTP2, because we need to know if the web and your clients, as the browsers, are ready to support this protocol. So since we do have internet connection here, we'll just go to the live website instead of the screenshots. So we're looking at the Can I Use website, and this is the current statistics for the HTTP2 protocol support in different browsers. So what we can see is that major browsers like the Microsoft, i.e. the latest version, the Edge browser, Firefox, and Chrome, also the Opera, they all support HTTP2. Some of the browsers don't support it, and the old versions of Internet Explorer, which actually have very low usage, they do not support HTTP2. The version 11 supports it, but it's only limited to the Windows 10 operating system. The major market share, according to this to the Can I Use website, it's with Chrome, and it supports it really well, except for some older versions. And obviously, the older versions of the browsers are going away, so that percentage is going to increase. Safari supports HTTP2 with the latest Mac OS, and the old versions of Safari don't. If we go to the iOS, it's the same thing here. And since we all know that the iPhones are updated more frequently, and the users are keeping their latest versions of iOS better than with other mobile systems, that percentage is expected to drop. If we look at the Opera Mini browser, that one does not support HTTP2, but basically Opera includes their own set of optimizations. They are acting as a proxy, and they are changing the content and making a bunch of their own changes themselves. So basically, this is not significantly relevant to our set of optimizations because they are including their own. If we look at the Android browser, oh, by the way, the Opera Mini operates in a similar way as the UC browser, which is used on many devices in China and some Asian countries. That browser also acts as their infrastructure behind that browser acts as a proxy with a set of their own optimizations. So the direct use of HTTP2 is not relevant to this browser as well. And if we look at the old Android browsers, those browsers do not support HTTP2 as well. But that share of the browsers is supposed to shrink significantly since users are updating to the newer phones all the time, and all the newer phones with the new Chrome for Android, they support HTTP2 properly. All right. So if we look at that through the overall stats, we'll see that about 70% of your clients are supposed to be supporting HTTP2. And if we take out this 8% and this 5%, basically we're in a very good shape for including HTTP2 in your general website infrastructure. And please remember, if you enable HTTP2 in basically all the implementations that I'm aware of, there is backwards compatibility, since if the web browser is not able to connect through HTTP2, it will most probably connect with HTTP1. There is about one use case when it won't, but it's very fringe use case. So let's get back to our slides. Instead of doing the screenshots, we looked at everything online. So the next page is the HTTP2 usage statistics from the W3Techs website. So we already see that it's used on more than 6% of the websites according to W3Techs. And also we can see that that percentage grew up significantly in the last couple of months. Basically, when I was submitting this talk to this event, we were at about 2 or 3%, somewhere in this range. Now it's basically tripled. If we look at the historic trend on the W3Techs here on this page, we'll see. On this page, we'll see that HTTP2 right here is the most growing site element at this point. Basically, everything else is staying on a flat line. And if we compare the HTTP2 growth with Speedy, we'll see that Speedy currently has about 6.6% of the website, and HTTP2 has 6.2%, starting with July 2015. So this is a very significant growth. And if we are implementing that today on our environments, we are staying at that growing curve, which should be really good for us. It must be something good in this protocol. All right, let's go back to the slides. Maybe not. Maybe not everything is good about this protocol. So first of all, there is a number of different downsides to HTTP2. One of those is I want to mention that not everybody needs to secure every particular request and every page. If your website mostly consists of cat pictures and funny videos, maybe encrypting every bit of that data is not really required. Also, if your website is mostly doing uploads and downloads of larger files, the HTTP2 optimizations, they don't affect that website that much. And maybe you just don't care about your website working a little bit faster. So sometimes it does, sometimes it doesn't make sense to implement this protocol. And there is one huge downside of the HTTP2 protocol. It's a little bit harder to troubleshoot. remember we looked at HTTP 1 request and response, and everybody was pretty much familiar with it. Everybody knew what that means. It's very readable. You can browse with telnet. Everything is fun and easy. However, if we look at HTTP 2 encrypted and even decrypted traffic, it is way harder to understand. You won't be able to perform HTTP 2 browsing from your telnet line. But even if we look at the encrypted traffic, and this is just the beginning of the TLS handshake, we can already see a few things there. We can see the client, my Chrome browser, is announcing that it works through HTTP 1, Speedy 3, and HTTP 2. H2 is the protocol identifier here. And also we can see that the server responds with the information that it works with HTTP 2 and with HTTP 1.1. So even though we can see this this handshake being completely unreadable, there is a bit of information we can extract from that without even decrypting everything. So what if we want to decrypt our browser traffic, and what if we want to look into inside of the HTTP 2 protocol and to see all of those streams, frames, headers, and all the other information? There is a way of doing that with Wireshark, and I really like Wireshark as a tool for troubleshooting. It gives me a lot of information on all the traffic that's going through my system. Everything is really easy. There is a way for us for doing decryption of your running browser traffic without the knowledge of the private keys of the servers that you're interacting with. The original way of decrypting the SSL traffic through Wireshark was related to you uploading the private key into the special Wireshark settings, and then basically I never liked it. It always meant that I would have to take the private key into the client system, and that doesn't sound like fun. So this way it's significantly more fun. You just need to specify the environment variable, the SSL keylog file, and you need to open the browser with that environment variable. And then what we need to do is we need to put that session key file into the SSL settings of the Wireshark. So once you do that, your traffic will become very readable, and the new versions of Wireshark, starting with I think with the version 2 of Wireshark, and currently they're at 2.01 or somewhere like along those lines, it does support the HTTP 2 protocol. So you can see this headers frame, settings frame, data, and all the other information there. This is definitely something that makes sense to research a little bit further. You will be able to see all the headers that are coming through, all your cookies, cache information, and so on. So for the troubleshooting part of HTTP 2, I definitely recommend using this approach. All right, let's go to the interesting part, the benchmarks. So everybody knows how to make their own benchmarks, and everybody makes the best ones. So at NGINX Conf 2015 in September, we had a talk by Valentin Bartenev, one of our core developers on HTTP 2, and that talk had a bit of a pessimistic view on that protocol. So what we looked at was a set of different tests with some pre-generated page, and those tests showed something quite interesting. So where's really the benefit of that protocol if we look at this graph? On the horizontal axis, you see the latency of the web server, basically your delay, your network delay to the web server. And on the vertical axis, you can see the first paint time for the page. So the page starts appearing on your web browser, let's say between, at 300 millisecond delay, you're expecting the page to appear in between 2 and 2.5 seconds. So the difference is not that significant between the HTTP 1 unencrypted, HTTP 2, and HTTP 1 encrypted. So the blue ones are HTTP 1, the green ones are HTTP 2, the yellow ones are HTTPS, so with HTTP 1. So if we put that on a different scale, the graph looks like that. Basically, we can see that HTTP 2, the black line only has a tiny bit of benefits over an encrypted protocol, and the benefit with the benefit compared to HTTPS is also not that huge. So we're starting to figure out what's the deal here, why people are so excited about it, and why is it, when does it work and when it doesn't work. So I did my own benchmark. And my own benchmark included the NGINX 199, the Ubuntu 15.10 with the OpenSSL 102 with the LPN negotiation. I used the Chrome browser. And what I did, I just put my page in a constant reload with no caches enabled to see how fast will that page reload. And then I started to figure out what kind of page I should be using for benchmarks. I'm pretty sure not two of us will have exactly the same page in our websites. They are completely different. We're using different client and server-side technologies. Some of our pages are extremely simple, like my home page, or they can be extremely complicated, like NGINX corporate website, the NGINX.com. So your mileage may vary. What I did, I took the benchmark page from the current free CSS templates, and I chose the one that looks reasonably modern. It is using some jQuery JavaScript. It's using lots of CSS, proper markup, and I added a little bit more images to that. So I made the whole page to have the total of 54 different objects. So I figured it looks like pretty reasonable setup. Maybe your websites are they have more objects like that, maybe less than 54. So there would be an interesting show of hands here. So for your web project, are your web projects, do they usually have more than 54 objects? And less than 54 objects? Okay, about the same amount of people. So we'll consider that to be something like a median page size. All right. So I started measuring that HTTP1, encrypted HTTP1 and HTTP2 for the same page within the constant reload. So what we are looking at here is a very interesting set of results. What I did for this test, I disabled the keep alive. So every HTTPS connection required the full TLS handshake. And when our latency grows, we found that it affects performance of the web page very significantly. So on around 100, so we can see that at a 200 millisecond delay, our page loads for more than 12 seconds on average. And if our delay is around 20 milliseconds, we're somewhere at 1 or 2 second page load time. So next thing I did, I enabled the keep alive and ran the same tests again. Once again, it was the constant reload of the page. So for the keep alive connections, we're taking away the initial SSL and the TLS negotiation from both HTTP2 and to our original setup, we can see that the latency here goes to up to 800 milliseconds. And right there at 800 milliseconds, we originally saw that there was some more significant difference between those protocols. So I went ahead and I increased my latency up to 1 second. What was quite interesting in the 1 second delay is that the benefits of HTTP2 they seem to be shrinking. So if your network delay is extremely high, let's say if you have satellite connections or most of your clients are coming from a completely different part of the world, or you're using 2G connections or something like that, you might see that even though the benefits exist, and they are still quite substantial, they are not as noticeable as the benefits on the lower delay. So what I did next is I divided one by another, and I got this unusual graph, which is a percentage benefit of HTTP2. And it looks very interesting that once again, for that page that I was using, because your page will be different, for the page that I was using in that benchmark, the best results for HTTP2 were at about 250, 300 millisecond delay, which is quite reasonable and very much real-world network delay. So that's the very interesting set of benchmarks, and this is the graph which I think shows that my benchmark is the best. All right. By the way, if you want to argue about this setup, I will be hanging out here for the rest of the day, and I will be happy to engage in any technical conversation or show you how that benchmark works. So let's go into a little bit of practical set of practical slides about implementing HTTP2 for your websites with NGINX. What we need to do is we need to take one of I would take the latest version of NGINX, which is 199 currently, and for the configuration, I would use the configure parameters for HTTP v2 module and with HTTP SSL module. It will technically compile without SSL, but how would you use it since no browser is using that anyway? When you are using the pre-built packages of NGINX or someone has built it for you, you can check with NGINX-V. You will see the configure arguments, and if you see the HTTP v2 module, it means you can use it. So the setup, your configuration for NGINX for HTTP2 is extremely simple. For your listen parameter, where you have your port number and the protocol, you need to add the HTTP2 together with the SSL parameter. Basically, that's pretty much it. So for the SSL certificate and the keys, you should definitely use more security than that is shown at this example. The security aspect of having the proper keys, protocols, perfect forward secrecy setup, and so on, that is a little bit outside of the scope of this talk. I definitely recommend looking through the slides and the presentations from the security track. Many of the presenters were using NGINX as an example, and they showed very nice configuration snippets, SSL parameters, and other methods of making your site secure. So definitely a great track to revisit if you haven't already. When you have your clients coming to your website, you will need to figure out how many of those clients are in fact using that HTTP2 connection. Are they using it at all? So in your logs, your variable request will show get and post requests with HTTP2/2.0. So basically, you will be able to find all that information in the logs, and you can parse those logs easily to figure out the percentages of your traffic to see how your own usage of HTTP2 is growing in the wild. And also there is another tool for that. We recently built, and we are in the process of building the monitoring system for NGINX, which is called NGINX Amplify. Basically, you can connect your running NGINX instances with a small agent to the Amplify SaaS-based performance monitoring tool. It will give you the configuration recommendations. It will give you a number of different graphs, and also it will give you the HTTP version graph, which will show how many users are going through going to your website with HTTP 1 or HTTP 2. Very useful tool. You will find the link to that in the link set that I will send that I will show here at the end of the presentation. So the useful tools that you can use for implementing this protocol, definitely you can monitor the usage of different web technologies with the Can I Use website. I found it very useful for figuring out what I should use and what I shouldn't. There is a great tool for encryption. Well, not all of us have corporate certificate authorities and access to expensive SSL certificates. So Let's Encrypt gives you an ability to generate free and supported SSL certificates for your websites. They will have 3 months validity, but they will be accepted by the major browsers, which is a very big deal, very useful for smaller developer projects and so on. And the web page test tool gives you the diagrams of how your page is loading in different browsers from the different parts of the world. Obviously, you can test your website from your own location, but having the flexibility of that tool, checking your web page performance from other places is very important. So I definitely recommend using that tool. A little bit about NGINX. So you can contribute to NGINX project at the hg.nginx.org. You can find all the current source code, and you can download it. You can write to the mailing list, to the developer mailing list, or the users mailing lists. Also, you can you can just grab current NGINX sources from GitHub. It's a read-only mirror. And if you don't like or don't want to code but still want to contribute, there is a wiki, and all of the modules, and at every project in the world, we all need the better documentation. The last link shows you an interesting promotion that we have for the Scale conference. We are giving you non-production developer licenses for the commercially available NGINX Plus with the commercial features. And if you want to test out that software without the restrictions of a free trial, you can do that on a yearly based license for non-production use. So I will leave this slide again on the screen, and if you have any questions, please ask those questions. I also have some NGINX stickers, so please go ahead. It does enable HTTP 1 as well. So let me repeat the question. So when we enable HTTP 2 in the listen directive, does it only limit it to HTTP 2 or also enables HTTP 1? Yes, it does have. The HTTP 2 connectivity will have to be negotiated by the client, by the client and the server. If they don't negotiate HTTP 2, they will revert to HTTP 1. I will have to think about that. Send me a note, please. I will respond to that soon. That will probably involve a change in the code.
Okay. My other question, my small comment is when you go to Let's Encrypt, if it freaks you out that their client tries to run as root, there are non-root clients. So it is a really cool project, but I've seen a lot of people panic because of the fact that it's pseudos immediately. So there are ways to do it without it, but do use Let's Encrypt.
Absolutely. Let's Encrypt is a great project, that's a fact. All right, you were next.
Yeah, you mentioned something about Wireshark, but typically when I'm on a server and I'm debugging things, I don't have a GUI available. Do any of the command line tools support not decrypting, but the encoding of HTTP2, like T-Shark or TCP-dump or anything like that?
Not sure about TCP-dump being able to. So the question was about the command line tools being able to support HTTP2 and decryption of it. What I would do in this case, I would probably take the TCP-dump pickup file and open it locally with Wireshark. Yes, I understand. The command line tools and the developer tools for HTTP2 protocols are something that is in active development. So this is something that's changing on the fly. We should expect more of those tools available. Yes, please.
Imagine a web app. I'm building a web app that's constructed using AMD or ES6 import. Lots and lots of components that depend on other components and have a relatively deep dependency graph.
Mm-hmm.
How would the depth of that graph have an effect on the benchmarks that you were showing?
So the depth of the graph, if you are using a lot of elements on the page, I found that when we have more elements on the page, you have usually better, more benefit with HTTP2. I can give you an example right here. So when we go into our list of links, there is a side-by-side comparison. Here you go. And this page shows you 165 small elements, small images here. So all of those are small parts of one page. So when it will restart, you will see again how fast or how slow those connections are. Also, that page is publicly available. You can see the whole NGINX configuration below. Yes, please.
On one of your earlier slides, one of the points you said was the server push.
Yes.
Unique to HTTP2.
Server push is a technology that is defined in the standard of HTTP2. Unfortunately, it's not currently implemented in the NGINX configuration or NGINX code, but it is defined in the standard.
Is it on your roadmap, or is it?
We are working on it. It's really. We can have a separate discussion of how server push should work through a proxy, but sending the request and response back through a proxy is not as simple as it sounds. Yes. Yes. Yeah, please.
I know most of your talk is about between browsers and servers, but in the space of RESTful APIs, does HTTP2 have an advantage over?
For the RESTful APIs and not just the browser connections, your clients can use HTTP2 for different other APIs and not just for the web pages. Probably the benefits will be significant for because of the header compression. With many API calls, the payload is quite minimal, but the headers can be significantly more than the payload. Depends on the traffic flow. Not sure that multiple streams and prioritization would be a huge benefit. Well, we'll have to see how your API traffic flow would work on that case. Also, if you are building your own clients, building them with HTTP2 is something quite new. So you would have to perform more research and more troubleshooting on that area as well. Yes.
Sorry, I have another one. Do you have any idea why the movement to HTTP was made away from?
Yes. So when we will look at these frequently asked questions, it will tell you that gzip compression with SPDY was prone to some significant vulnerabilities, and the standard defined the new way of doing that with HPAC, which is prone to those vulnerabilities. That's the major reason. Mm-hmm. Yes, please.
One kind of clarifying question on the HTTP2 push feature. So is it only used for the use case, like you are going to soon need this static file, or can it ever be used on the application level, a little bit like WebSocket,
It's
as a notification mechanism?
Yes, it is supposed to be used with the both ways, and as you said, as a replacement to WebSocket at some point as well. WebSockets over HTTP2 is something. Well, there is a draft. It exists on how to implement WebSockets with HTTP2 or over a speedy protocol, but that is not currently in the standard. So basically, when you want to implement WebSockets, when your sites are running HTTP2, the browser will be smart enough to not go with HTTP2 when you want to upgrade to a WebSocket connection. So the browser will go HTTP1 for that particular connection. You can still use WebSockets on your website. It will not be HTTP2 enabled currently. All right. Well, it looks like we're out of questions, but anyway, I'm handing out around this room and outside until the end of the hour, and you're welcome to grab some stickers. So, thank you.